This is our intro to improper integrals. And so we're going to be taking integrals now that are going to infinity, to negative infinity, to points of discontinuity. And this is the first type that we're going to be using, and these are to infinity. So what we have is our integral of f of x dx from a to infinity. And so what we're going to do is take that and rewrite it as a limit as t approaches infinity, and then we'll place a t in the place of the infinity. And these are equal, so we can use this. So let's take a look at it. This would equal 1 to infinity would equal the limit as t approaches infinity. And then, like I said, we just put, oops, our a here is 1. And then we put a t up there, 1 over x squared dx, like that. So all you're going to do is take the infinity, replace it with a t, and then say the limit as t approaches infinity. And then now what we want to do is integrate this, and then we'll plug in the t and the 1 and take the limit. So rewrite the integral, just the integral part, no t, no 1, nothing. And so then we say that this is x to the negative 2 dx, and then we just take the integral. So remember, we add 1, so x to the negative 1, but don't put plus c here. All right, and then now what we're going to do is take that little part that we just found, drag it over here, and replace it. So all we're going to do is take and replace this part right here with this. Okay, so then we write the limit as t approaches infinity, and since this is a definite integral, we put t in 1, like that. So that's all you're going to do. Now we have a function that we can use to find the limit of. So the limit as t approaches infinity of, let's rewrite it now as 1 over x, so that would be 1 over t, plus, because we have to change the sign, 1 over 1. So all I've done is put the x on the bottom and plugged in the t, put the x on the bottom and plugged in the 1. It's a minus, that would be a minus, so we now have this. So this is our limit function. If you remember all of our limits, we've gone through some. You can go back and grab our note page and look at it for what we have for limits for rational expressions, for tangents, for exponentials and logarithms. Each of those are being used. So if you remember the limit of our fractions as t approaches infinity or negative infinity of 1 over t, and we'll call it an r, where r is greater than 0, we know that that is going to equal 0. So we know this one is going to go to 0. So this ends up equaling 0 plus 1, which is 1. Now to verify this, we do want to be able to use our calculator. So what you're going to be plugging in is not this, but what it becomes. And so this is the function we're going to plug in. Just like normal limits, we want to take a look at the way it looks. So we have negative 1 over x plus 1. That's what we had here. And then you go to your table set. We're going from 1 to infinity, so I put my change in table of 1,000. You can make it anything you want as long as it's getting really big quickly. And then we go to our table. And you can see what it's approaching. It's getting closer and closer and closer to 1, exactly. So this is our introduction. In the next video, we'll take this a little bit to another step, which is not much more, just looking at it as if we go to negative infinity. But let's look at our Desmos graph real quick so that you can see this. So this is what's really happening, right? We're at 1. I'm going to actually put this at 2 so you can see that. And again, the link is right there in the lecture notes. So we're at 2. And you can then see it went really, really quick. But look at the number we're approaching. So as our b goes off to infinity, because that's what's happening here, our a is 1, our b is going off to infinity. So we can see our integral here, and it goes off to infinity. You can see it's getting closer and closer and closer to 1. So eventually, it's never going to hit 1, but it's getting closer and closer. You can see we're just getting more and more 9s, 9, 9, 9, 9, 9, 9, 9, all the way down, but it is approaching 1. So if we were to go on forever, the area under the curve would be 1. So the integral from 1 to infinity of 1 over x squared dx through all of our work is 1.